Today we will be discussing about one question from solid state chemistry. It's related to fluoride structure. Let's read the question. PbO2 forms a fluoride structure with A is equal to 5.349 angstrom. Find the shortest PbO and OO distances in the structure. Okay, the important points given are: one is PbO2 forms a fluoride structure. We need to know what is the structure of fluoride, and we need to find PbO and OO distances. So first of all, you need to know what is a fluoride structure. Fluoride structure. So similar kind of structure is also you might have learned. Another one is anti-fluoride structure. Anti-fluoride structure. Okay, in fluoride structure, the example given is PbO2. This question is all about fluoride structure. PbO2, this is the cation. Lead is the cation and oxygen, O2 minus. This is the anion. Okay, lead is in 4 plus oxidation state and oxygen is in 2 minus oxidation state. Net oxidation state is 0. Okay, I am explaining these things, but in this question we don't learn all the things, but the basic idea of this question, why I took this question is you need to know what is fluoride structure and what is anti-fluoride structure. That is the ultimate aim of this question. Okay, I'm not concerned about the result or anything, just I'm focusing on fluoride structure and anti-fluoride structure. Okay, the cation, then what is the position of this cation is occurring at FCC. This occupy at FCC lattice and anion is at all the tetrahedral oids. Then what is a FCC lattice? What does that mean? FCC lattice means atoms or ions are occupying at the corners plus phase center. FCC lattice. Okay, and tetrahedral oids means you might know tetrahedral oids. Suppose one cube is, I'm drawing one cube. In this cube, the tetrahedral oid is, suppose this is the body diagonal and this is another body diagonal. This 1/4 of this body diagonal here, this is one tetrahedral oid, and the similar way here is one tetrahedral oid, here is one tetrahedral oid, here is one tetrahedral oid. Similar way we can draw another two diagonals from here to here and from here to here. So there are total 8. 4 I draw here, 4 we can again draw 4. Total 8 tetrahedral oids are present here. Okay, total number of tetrahedral oids are 8 tetrahedral oids. So once again I am telling fluoride structure, the cation occupies at the FCC lattice and anion occupies at all the tetrahedral oids. What is the FCC lattice means? FCC lattice means the corners and phase center. Okay, then I will come into anti-fluoride structure. Anti-fluoride structure, the example is Na2O is an example of anti-fluoride structure, just opposite of this structure. Here the cations are here, this is the cation, this is the anion. Here the cations occupies at all the tetrahedral oids. The reverse of that, all the tetrahedral oids. Okay, and the anions, O2 minus, here O2 minus occupies at the FCC lattice, just opposite FCC lattice. This is the things you need to know in this question. Okay, then we can solve the question. So I'm going to draw the structure. This is the fluoride structure. So lead atoms FCC lead atoms occupy at the corners and phase center. Okay, lead atom I am drawing it in this color at the corners and face center. Okay, here all the 6 faces. Okay, here and the top. Okay, this is the lead atom. Lead atom I am drawing it in this color. Okay, this is lead atom, Pb. And what is the next atom? Oxygen atom. Oxygen atom occupied all the tetrahedral voids. All the tetrahedral voids will come near to, suppose I am drawing one body diagonal. See, this is a 1/4 of this position. This is the oxygen atom. Okay, another oxygen atom will come near here, 1/4. Okay, this is the oxygen atom, and this 1/4 of this body diagonal. Okay, now we need to know what is a PBO and OO distances in the structure. So A is given in question. A is given as A is equal to the distance. This is the A distance. This is given as 5.349 angstrom. Okay, this will also be 5.349 angstrom. Then this is a cube. The diagonal of a cube, you know the diagonal of a cube, the equation diagonal of a cube. The equation for diagonal of a cube, if one side is A, then diagonal is √3a. If you are not aware about this, you can easily find from Pythagoras theorem. Suppose this is 5 and this is also 5, then this is the face diagonal √2a, right? Using Pythagoras theorem you can find this one. This will be √2a, and this one also from √2a, and this is a. Then using this triangle, I am telling, if you are not aware about this equation, the diagonal of a cube, if you are not a face, this is body diagonal, then you can easily find from this triangle. Okay, if you are not aware about any equations, okay, a √2a, then you can find this equation. Okay, this side, this is the body diagonal, √3a. okay, then we can directly substitute distance of PBO. Okay, this is the body diagonal. We need to find PBO. This distance we need to find. Okay, this distance. This is the 1/4 of this long diagonal. Okay, then 1/4 into the total diagonal √3a. Okay, then 1/4 into √3a. A is 5.349. Then the answer you can find, it's 2.316 angstrom. This is the answer. Okay, the only thing you need to know the fluorite structure, the geometry of fluorite structure, and here you are not dealing with anti-fluorite structure. And next one more thing they ask, what is the OO distance, right? OO distance. OO distance means this distance. OO distance is very easy. The distance OO is equal to A/2. A is equal to, how it's we got A, because this distance, this is 1/4 from this side, this face, 1/4 from this face, and 1/4 from this side. There is nothing is there. Then we need to find only this distance. Okay, that means 1/4 reduced from this side. Total distance is A. 1/4 reduced from here and 1/4 reduced from here. That means total A minus 0.5, that is A/2 is equal to 5.349 divided by 2, 2.6745. This is the answer. Okay.